Example 5.12 or 6.12 for the given textbooks. For details, please see the description below. A rigid insulated tank that is initially evacuated is connected through a valve to a supply line that it carries steam at 1 megapascal and 300 Celsius. Now that the valve is open, the steam is allowed to flow slowly into the tank until the pressure reaches 1 megapascal, at which point the valve is closed. Determine the final temperature of the steam in the tank. The first step is to write the mass conservation. Notice that this is an unsteady problem, and we write the mass balance in the following way. The mass going in minus the mass leaving has to be equal to the change of the mass in the system, which means that is simply the final mass minus the initial mass inside of the control volume. If you notice from the example, it says that at the beginning, the mass in the tank is equal to 0. So M1 is equal to 0. Notice that also if we take the tank, there is no mass leaving the system. So therefore, MO is also equal to 0. Notice that we are taking the actual tank to be the control volume, and that's what allows us to write this quantity. If we cancel out, this is going to be 0, and this is going to be 0. Therefore, the mass going into the tank is basically the mass that is going to be at the end of the process. Now let's do the same process for the energy. The amount of energy in minus the amount of energy out has to be equal to the amount of change energy in the system. That means that is basically the final energy minus the initial energy. The amount of energy going in is simply going to be the mass times the enthalpy going in. The amount of energy leaving is the mass leaving and the enthalpy leaving. And the amount of at the beginning and at the end of the process is going to be an addition of a potential energy, kinetic energy, and internal energy. However, in this process, we're going to neglect the amount of change between kinetic and potential energy. Therefore, this simply reduces to the mass at the last stage times the internal energy at the last stage minus M1 U1. Based on the cancellations that we had before, M1 is equal to 0 and M out is also equal to 0. Therefore, mass in H n is equal to mass 2 U2. And since we have these two masses to be equal to each other, it tells us that the enthalpy going in is equal to the amount of internal energy at the end. Now we're going to go to the tables to find the desired values for this state. In order for us to get the values of enthalpy and internal energy, we're going to go to table A6, since the problem states that the fluid is steam. We go to the pressure of 1 megapascal, as is stated at the entrance, and we go to the temperature of 300 Celsius. And then we find that the enthalpy is equal to 3051.6 kilojoules per kilogram. Based on the balance of energy, we found that that's exactly the same amount of internal energy at the last state. So we go and notice that is between 400 and 500 Celsius. And then we'll write these values so that we could interpolate. Using these values, we're going to interpolate in order to be able to get the values of the temperature for the corresponding internal energy. So we have 400, and then we simply say 500 minus 400. This is the temperature, and then we simply said 3051.6 minus 2957.6 divided by 3125 minus 2957.6, and we solve for x, and we find that the value of x, which is basically the final temperature, gives us 456.15 Celsius, which is a value higher than the initial temperature that we have going into the tank.